Okay, good morning all. Yesterday, one of the students has been done the shaft. Bob already started draw the shaft for treadmill. So the treadmill here, the two different shaft is this one and this one. So this is two important part to drive the belt on top. Without this, the belt won't be turned. This is a flat surface and there's a smaller surface here. And so therefore you can insert the tooth here. And also you can put the bearings on. And same as this. This one there, you got the crop wheel for the gear and the motor is here. And then the drive the gear and they can turn. This one there and this one there must be the same size. That's the first drawing. That's all incorrect. I think there's a lot of problem from this drawing. I give you a little bit of instruction and come out with this. But this one, it looks different sizes. As what I said before, the surface of here must be the same size. And on the side there, you don't need a screw because you got the bearing will cover here to holding both sides. If you don't have this groove, you can have the same sizes. However, if the same size is very difficult or a little bit difficult for you to lock in the bearing here. So by shaking, this shaft can be moved out and also not easy to make an adjustment. If you put a screw here, you tighten them, the shaft won't be turned. And same as here, there's nothing like this two end in here. The other problem is I think this is not wide enough or this is too much. Let's come back to here. So if I identify the sizes between here to there, maybe from this groove to there is, for example, is 500. Based on the information, I'm going to make a drawing. So standard, create, and then I start the 2D drawing. Doesn't matter which plan you're going to use. First thing I do, the raw size. Okay, come back to the raw size. I maybe say 50 mil. So when I turn green, type in 50 mil. No, it's okay. So the second one, let's talk about this part. Okay, so this part I would like to say 45 mil. So 45 mil, that means this one is 2.5 mil. It is okay. Clip in the bearing. How big the bearing is, we need to work out. The internal size of the bearing is 45, so you can put it in. Okay, so I finished my drawing. So extrude. Okay, I would like to go the other side. So how far I need to go? At the moment it's 10 mil. As what I said before, I want to have 500 mil. So I put it in 500. Okay, so that's 500 mil. Crossover from one end to the other end. That's not the size we clip in the frame. Remember, we have not the surface there. So I would like to do right hand click. I want the visible. All right, so I can see it. Okay, now extrude, and this one now. This one, I would say 30 mil. And okay, so 30 mil. And I would say that's, I finished one side. Let's come back here. As I mentioned before, that's a driving shaft. Driving shaft, there's no power need. So when the belt turning, it's just turning. When you have a car, we say two-wheel drive, you only drive the front shaft. The rear shaft just slave. They're just running. So therefore, you don't need any gear. But both sides, you need to attach to a bearing. I don't have the other side, the shaft for the bearing. I just get sketch. So now if I turn around, I can see it's right there. That's okay if upside down. So I got project, geometric. I highlight this one, and also I highlight this one. And then I get through a circle to there. All right, finish. It's okay, and finish. Extra, this part, 30. I got both sides now. It looks good to me. There's no problem at all. That's the driving parts. I already finished. If I want to select the material, I would like to select the one no rust, no plastic, no PVC, no polyester. Maybe polyester is okay, but it is very easy to worn out. So you can choose stainless steel. If I want to do the stainless steel, I just pull stainless steel. Yeah, it never rusted and strong enough to holding everything. So they should be the one Bob just showing in here. This one there. You don't need this. You only need these longer parts as a shaft. In case some of the people say, I want to put a bearing there, but I still need to lock in. I don't want to lose this one. So they move in and out or whatever. If you don't put right in the corner there, and they will lose out. So you can put a pinhole there and insert a pin in there. You can do it. Not necessarily say I don't need it. The sharp edges. So I can use the filler. This is only 2.5 mil. So just be careful. Maybe I change the size to 1 mil. That's 1 mil. And then 1 mil there. And all around. Just be careful. And this is not big enough if you put too big. Okay, so that's the finished products. That's how they look like. So this one's a driver shaft. How do we make the driver shaft? That's why I mentioned before, you need to have a crop wheels, you need to have a gear to driven by the motor. And I get save as. I just put in the documents, driving shaft. Okay, I saved this one. Already been saved. So what I'm doing is I can modify this. All the different is I'm going to put a gear in here, right in the corner here. So between here to there is 30 mil. Remember, offset. Get this one, and then I get. You see the arrows here is pointing to this way. So I put minus 30 and enter. So the surface going there. So what I'm doing now is go to sketch, perfect, right, and go to do the project geometric. This one. The reason we can do few is because we don't know which one we're going to use. We don't have any figures. So if I come to the center point there, it turns green, and then I make because the gear must be bigger than the flat surface of the shaft. So therefore I put 60 maybe. Again, I don't have any sizes. That's why I'm not going to do exactly what I want. And then draw a line there. Okay, you won't see it. You don't see the lines there. You see the lines there. Why? Because you're drawing on this surface. I don't want to turn this one off. I can't turn it off. However, I just keep going like this because the only parts we need is in here. All right. Okay, draw another line. And this time there, this is 90 degree. If I turn to here, you're getting a little bit bigger. So 104.88 degree or 100. So what I want to do is I put 98. So tab 98. All right, so I have another one. Okay, so now I'm going to draw another one. I need another one. So I need 3 points. The gear started from here to there. Yeah, I need a little bit of curve. So that's a start point. That's the end point there. Okay, so let's draw another line. And at this time, the line roughly in there. So I put 93. What I'm doing is use the arc, 3 points arc. I can use maybe this point, and this one. There, here, and here. You see the half circle doesn't really matter. So I use trim function, trim L, trim function, trim L. You don't need all these. You don't need these. You don't need these. Trim this out, trim this out. And all these ones go out. And I leave this one for now. I leave this one for now. And this one can go out. Let's see. And this one, I leave it. This one, I can take it out. And this one, I can take it out. Okay, all unnecessary has been removed. I need to trim this out. At the moment, only this one and this one leave there. And this is another one we needed. Okay, so let's go to, and just escape. And go to mirror. Okay, select. I select this one and this one, and that's all. And mirror line is this one. Apply to go in there. All right, done. I'm just drawing this one. Yeah, now we got this line. So which is ribbon, and you can make it 3D, but that's okay. Circular. Let's select all these again, and select the S's, and then I put 18, or I put a little bit more, 20. Oh, 20 is good. It has been created. So I'm happy with these results. I'm going to close this sketch. So extrude, can extrude this one. Let's say 10 mil. 10 mils are good. But the other way, you don't want to interfering of this side because they half hang. They half hang. Okay, go to the other side. All right, all done. Okay, so now has been done. It is good results. You can always drive in this shaft. So that's a finished product. If I try to turn this, I can turning. So the shaft is turning by the motor. And you put the bearings here and put the bearing here. And some people say, I want to lock the bearing in. So I make a little hole there and put a screw in. Go to save as. Before I said driving shaft, now I put it in driver shaft. So I got two different ones. All right, if I want to create assembly drawing, and then I can place some of the drawings I created. Okay, and open the other one. This is driven, so I'm looking for driver now. Okay, so 2 of them. So now we've got 2. If you put the bell on and the cover on the side, bearing, motor in here, it will be the power for your treadmill. Thank you and enjoy the drawing for the day. Bye for now.